good day everyone. My name is Aerodynamics Lexi Beaver of BSAE 3-2. So today we're asked to create a video for the Module 3. Create a sample problem covering 2 to 3 areas of the module. So for this example, I will be focusing more on pressure, temperature, density, Mach number relations. So for the problem, determine the reservoir pressure, take note the reservoir, density, and temperature of the supersonic wind tunnel if the Mach number at the test section is at 1.2. So we have a given of Mach number which is 1.2 and we are tasked to find the pressure, density, and temperature in the reservoir. So knowing that outside the perimeter, we have the standard condition, which means that we also have the may nararamdamang pressure, temperature, and density yung outside condition natin. So that will be our pressure number 1. So at SSLC, ang temperature natin, ang pressure natin, at ang density natin, i-categorize natin siya as 1. Meanwhile, yung reservoir natin is i-categorize natin siya as pressure 2, temperature 2, and density 2. So, knowing the formula of the Mach number relations to temperature, pressure, and density, gagamitin na natin yung direct formula nun. So, we have for the temperature, we have for the pressure, and we also have for the density. So, again, yung 2 natin, like ito yung hahanapin natin. Ito yung hinahanap natin, yung nasa reservoir niya. So, basic algebra lang, we need to divide the entire equation to SSLC para makuha natin yung hinahanap natin sa reservoir. So, again, temperature 1 divided by K minus 1 over 2, Mach number squared plus 1. So, our temperature will be 519, which is, again, SSLC, over 1.4 minus 1 over 2 times 1.2 squared plus 1. So, we will have a temperature of approximately 402.9503.106 Rankine. So that will be our temperature in the reservoir. Pero may ibang mga problem na since wala nang given na SSLC, hindi mo pwedeng assume na nasa SSLC sila. So, iaano mo yung final answer as in terms of that particular na missing. So, halimbawa, T2. Ayan, di ba? Hindi natin alam to. So, kung hindi natin alam tong part na to, ito yung iaano natin so magiging in terms of T1 siya yung kalalabasan niya. So, yung pressure naman is ganun din. Pressure at SSLC is 2116.8. So, we are using English. So, 1.4 minus 1 over 2. 1.2 squared plus 1 raised to 1.4 over 1.4 minus 1. Our pressure will be 872.9197.232 pound per square feet, PSF. So, ayan. And lastly, for our density, again, ito yung hinahanap natin. So, divide both sides by the entire equation. So, lalabas ang density natin as 1.262523656 times 10 raised to negative 3 slugs per cubic feet. So, ayan yung mismong value ng ating temperature, pressure, and density sa ating reservoir. For the sample problem number 2, a supersonic tunnel has a reservoir temperature and pressure that are 900 Kelvin and 5 atmosphere respectively. The static temperature of the throat and exit are 700 Kelvin and 200 Kelvin respectively. The coefficient of pressure is equal to the 1008 joules per kilogram Kelvin. Calculate the velocity at throat and calculate the velocity at exit. So here we have the temperature at the reservoir, T1, temperature at the throat, T2, and temperature at exit, which is 200. So we also have the CP for the air, which is 1008 joules per kilogram Kelvin. So kapag hindi given, hahanapin. Kapag given, ito na yung gagamitin. So throat and exit. So first, we all know the given or the formula for the supersonic is CPTO plus 1/2 VO squared is equal to CP temperature 2 plus 1/2 velocity squared. So, saan nanggaling to? Ito, nanggaling to sa dynamic pressure, ay dynamic, which is yung kinetic energy. And ito, nanggaling siya sa enthalpy equation, which will give us the energy equation. Ito tong nasa taas na. So, in the reservoir, we all know that the velocity is 0. So, canceling the velocity, that would leave us to CPTO is equal to CP temperature at the throat and the velocity at the throat. Since ito yung hinahanap natin, i-isolate natin siya palabas. So, ta-transpose lang natin to sa kabila, magiging minus. Then, i-factor out natin yung CP since pareho silang equation or pareho silang equation ng CP. So, CPTO minus T sa throat times 2 kasi itong 1/2 dito inangat natin doon. So, for the velocity ng throat is, ayan, 2 times 1008 times the difference between 900 and 700, that would be equal to 634.9803147 meter per second. So, punta tayo sa analysis niya, sa unit analysis, dimensional analysis niya. So, si joules ay alam natin, siya ay Newton meter. Si Newton meter naman, alam natin na siya ay kilogram meter per second squared. So, having this equation sa numerator over kilogram, makakancel yung kilogram natin. That would leave us to meter squared and second squared. And since square root tayo, makakancel lang yung square dyan. Ang matitira is meter per second. So, for the velocity at the exit, same thing gagawin natin. I-relate natin siya sa mismong reservoir. Doon tayo magde-reference point. Since, ayan nga, drawing ko na. Kanina nag-reference tayo reservoir to throat. Ngayon, reservoir to exit. So, gagamitin natin velocity sa reservoir is 0. Kasi nga nasa reservoir siya. That would leave us to CPTO at the reservoir and CPT3 temperature at the exit plus 1/2 velocity at the exit squared. Ngayon, isolate the velocity. That would leave us to the velocity in the exit is equal to the square root of 2CP times the difference between the TO, which is the reservoir, and the exit temperature. So, having that, we will have a final answer of 1187.939392 meter per second. So, again, sa dimensional analysis, ganun pa din, kagaya nung nangyari doon kanina. So, again, itong example na to, is example for the wind tunnel setting and compressible flow analysis. So that would be all. Thank you.